Hello, my name is Shaika Lee, and I prepared this website because over the course of making my science fair project, I discovered that I had a very amazing passion for space. Space was not a subject I could do, so I decided to go a bit deeper, and I found black holes. It took me a very long time to understand some of the deeper concepts, like the information paradox. That's why I put together this website to show aspiring astronomers how these fascinating things work. Let's begin. So on the homepage, this website is all about black holes. It was made to present and paraphrase the data I have collected over time. If you already know about black holes, this website will sadly not help much. But if you seek more knowledge on this fascinating topic, then continue on. I sincerely hope that you find this helpful and enjoyable. There are a few misconceptions about black holes. 1, no, they do not suck things up like a vacuum cleaner. 2, no, they are not sentient beings out to destroy us all either. 3, black holes cannot appear on Earth, so we are safe, for now at least. So if black holes are not any of these things, then what are they? Well, simplified, they are extremely large collections of mass in an extremely small room. You can think about it like this. If you had a piece of paper, then crumpled it into a small ball, the properties are still the same. It doesn't change its mass or weight, but only gets smaller. Then what if instead of a piece of paper you had a neutron star? Then we get a black hole. Now we know a bit about black holes, let's look at the different parts of one. The event horizon. The event horizon is the point of no return. As soon as you cross it, the only way to escape is going faster than the speed of light itself. So, according to Einstein, it is impossible. The ergosphere/accretion disk. The ergosphere is located directly outside of the event horizon and is basically the cosmic whirlpool around a black hole. It is a hot mess of plasma and gases along with the churned up remains of whatever came too close. The singularity. The singularity is the whole of a black hole. It starts as the remains or corpse of a star after a supernova, but as it gains more mass by eating other planets, and stars, moons, and who knows what else, it grows and grows, adding the object's mass to its own, thus getting stronger and stronger gravitational pull. When a star is born from a nebula cloud, it has 2 major forces going on inside. Gravity, which is what holds all the planets in proper orbit, but could also pull the star in on itself. Luckily, there's radiation, which pushes back against the gravity, and so the star stays stable for billions of years. But then tragedy strikes. At the end of the star's life, the gravity gets much more powerful against the radiation, pushing so hard that the star collapses in on itself in an explosion with the force of a few octillion nuclear warheads blowing up in your face. This is called a supernova, but only a star with at least 6 times the mass of the sun will go down in a supernova and become a black hole. Now, in the process of eating everything like some insane intergalactic Pac-Man, black holes could delete the most fundamental thing in our universe: information. First, what is information? Information is commonly understood as the arrangement of particles. Think about it. If you have a few million atoms, then you have a rock. Change the arrangement, and you have a cup of coffee. Add a few more atoms, you have a dog. This is information. The number one rule of all our laws of physics, math, science, quantum mechanics is the same. Information is indestructible. Without this, none of our laws of physics work. Think about it like this. If you burned a piece of paper, that ash and smoke will never be paper again. But if you could carefully examine every last bit of ash and the heat radiating and a lot of other stuff that would take too long to list, you could, in theory, construct a copy of the paper. So the information is still there, only it's hard to find. But black holes destroy information. Now this is where black holes come in. When an object reaches the singularity, it basically morphs into the singularity, or becomes one with the singularity if you prefer that. But that means that the black hole makes different stuff the same. This means that a black hole destroys information. This causes the information paradox. There are three possible outcomes for this paradox. 1. Information is destroyed indefinitely and unstoppably. This means all our laws of physics are wrong, meaning that we have to restart from scratch all over again. 2. Information is hidden. Seeing as no one has been in a black hole yet, it is possible that the information is transported to some other place, like with the white hole theory, where we could never see or interact with it, but it's not lost. 3. Information is hidden. It is possible that the information gets encoded on the surface of the singularity. So as with the previous case, we would never see or interact with it, but it is technically still there. Now, I realized that this wouldn't really appeal to younger audiences, so I decided that if children are always playing games all the time, then I might as well make a game out of black hole. I made 2. The first one is a black hole all about me. It was made using Scratch programming platform, and this is it. Singularity is the source of all the mass and gravity. If you want to learn more, go to another project, link in description. It's supposed to simulate the effects a black hole would have on a human. So we can select our black hole. Right now it's stellar, we'll keep it stellar. I did a bit of research, and the normal human would spaghettify into a hot stream of plasma in less than a second, which is why he got so fast. And now it gained the mass. Now we could change it up and make it a supermassive black hole. Play. He spaghettifies much more slowly because science has proven that for the largest black holes, supermassive black holes, you could travel in them for quite a while before you died. Thank you for listening to this video. I hope that you enjoyed and learned a lot.